You are about to witness Earth transformed, not by impact, not by ice age, not by the slow creep of geological time, but by a single impossible reversal. What if water, the foundation of every living thing, could never form? Not destroyed, never missing, instead eternally separated into its raw atomic components, hydrogen and oxygen, floating freely as gases in an atmosphere that never knew oceans, never knew rain, never knew life. This isn't just a thought experiment. It's a doorway to understanding why our Earth is not merely fortunate, but improbably, impossibly precious. We take water for granted, a glass of it, a shower, rain on concrete, the vastness of oceans. But water is not inevitable. It's a cosmic accident, a specific arrangement of atoms that only forms under precise conditions. Change those conditions, and everything unravels. Today, we ask, what if the most fundamental accident of our existence, the formation of liquid water, had never occurred? What would Earth look like? What would become of atmosphere, climate, geology, and the greatest experiment in the universe, life itself? By the end of this journey, you'll understand something profound. Earth, as we know it, is not a default state. It's a miracle of chemistry, physics, and chance. The oceans, the forests, the creatures that walk and fly and swim, all of it depends on a single, fragile impossibility. Water can be liquid. Remove that possibility, and you remove everything we are. But before we despair, we need to understand why. We need to see, scientifically and viscerally, what happens when hydrogen and oxygen refuse to bond into the molecule of life. To understand what we're losing, we first need to understand what we have. Earth sits in what astronomers call the habitable zone, the Goldilocks region around our Sun, where it's neither too hot nor too cold for water to remain liquid. But distance from the Sun isn't the only factor. Water is remarkable because it can exist in 3 states across relatively narrow temperature ranges: ice, liquid, vapor. This versatility is rare in the universe. Most substances exist in only one state across most of the temperature spectrum. Water's structure makes it unique. 2 hydrogen atoms bonded to 1 oxygen atom at a specific angle. This geometry creates something extraordinary: the hydrogen bonds. Weak electromagnetic forces that make water sticky, cohesive, capable of dissolving almost anything. These bonds are why water can be liquid at the temperatures where Earth exists. The water cycle is Earth's circulatory system. The Sun evaporates water from oceans, lakes, and soil. This vapor rises into the atmosphere, where it cools. As it cools, hydrogen bonds strengthen, pulling the vapor molecules together. They condense into tiny droplets. Billions of droplets form clouds. These clouds drift across the planet. When conditions align, temperature drops further. Air becomes saturated. Precipitation occurs. Rain, snow, sleet. Water returns to the surface, filling aquifers, rivers, oceans. The cycle repeats, has repeated for billions of years, will repeat for billions more. This cycle does something profound. It distributes water globally. It regulates temperature. It enables weathering that creates soil. It powers weather systems that moderate climate. Without it, Earth would be unrecognizable. Every living thing on Earth is fundamentally water. Your body is roughly 60% water. A tree is 50%. A jellyfish is 95%. But water isn't just filling space. It's the medium in which chemistry happens, the chemistry of life. Water dissolves nutrients. It carries them into cells. It enables metabolic reactions. It lubricates movement. It regulates temperature through evaporative cooling. Water's ability to form hydrogen bonds means it can hold enormous amounts of energy. Energy released when it condenses. Energy absorbed when it evaporates. This thermal capacity makes water the ultimate climate moderator. Oceans absorb heat from the sun during summer months, then release it slowly during winter. Without oceans, Earth's temperature would swing wildly between extremes. Life requires stability. Life requires water. We are about to remove this. Not gradually, not by degrees, but by asking, what if the fundamental property of water, its ability to bond, condense, and form liquids, simply ceased to apply on Earth? What if, from the moment our planet formed, hydrogen and oxygen never bonded, or bonded only fleetingly before separating again? What if water could only ever exist as individual atoms, or at best as separate H2 and O2 gases, never as H2O liquid? The consequences ripple outward. Atmosphere changes. Temperature extremes emerge. Weather becomes alien. Geology transforms. Ecosystems that evolved over billions of years to depend on liquid water face something they never evolved to handle: its permanent absence. And life, complex, beautiful, impossibly intricate life, faces extinction not from catastrophe, but from the removal of the single prerequisite of existence. Let's establish the mechanics of this hypothetical. In reality, hydrogen and oxygen bond with tremendous strength. The reaction is explosive. Two H2 molecules plus one O2 molecule create water with tremendous energy release. This is why hydrogen is a rocket fuel. The bond is stable, powerful, thermodynamically favorable. For our scenario, we need to imagine a universe with slightly different physics, one where that bond doesn't form, or forms so weakly that it immediately breaks apart. We're not changing gravity or the speed of light. We're simply asking, what if the electromagnetic forces that attract hydrogen to oxygen never quite aligned? This isn't just academic. It helps us understand how finely tuned our existence is, how specific the chemistry must be for life to emerge. The first consequence manifests instantly. Earth's atmosphere, which currently contains roughly 78% nitrogen, 21% oxygen, and 1% argon, plus trace amounts of carbon dioxide and water vapor, becomes radically different. In our scenario, that water vapor doesn't condense into clouds or oceans. Instead, it remains as vapor, but can't exist as H2O molecules. The hydrogen and oxygen separate. Separately, they behave completely differently. Hydrogen, being the lightest element, would rapidly escape to space. Our planet's gravity is insufficient to hold hydrogen gas long-term. Over millions of years, hydrogen would gradually leak away into the solar wind. The net result, Earth loses hydrogen entirely. Oxygen, much heavier, remains trapped in the atmosphere. But free atomic oxygen in the upper atmosphere creates a problem. It oxidizes everything. Rock becomes more oxidized. Without water to moderate these reactions, chemical weathering accelerates dramatically, but in the wrong direction. Rock becomes brittle. The oxidizing environment becomes hostile to any chemistry we'd recognize as organic. Let's pause and consider what Earth's atmosphere would actually look like. We've lost water vapor entirely. We've lost hydrogen. We're left with an atmosphere dominated by nitrogen and oxygen. But oxygen now behaves differently without water to regulate its chemical reactions. The atmosphere becomes lighter overall. Atmospheric pressure decreases. If you stood on the surface, the air would feel thinner, like standing on a high mountain. But everywhere, breathing would be labored. Animals that evolved to extract oxygen from denser air would suffocate in this thinner atmosphere. Additionally, without clouds, without water vapor's greenhouse properties, the atmosphere loses significant insulation. Heat radiates away from the surface more efficiently. While the day side facing the sun would experience extreme temperatures, the night side would cool rapidly. Temperature differentials would be enormous, hundreds of degrees between sunrise and sunset at the equator. Without water's thermal regulation, surface temperatures become extreme. During the day, the equator could reach temperatures exceeding 80 degrees Celsius, hot enough to cook flesh, to melt plastics, to vaporize any remaining organic compounds. At night, especially at higher latitudes, temperatures plummet, -60, -80 degrees Celsius. Rock contracts and expands violently. This thermal stress fractures stone. Mountains crumble. Geological processes accelerate dramatically. The poles become incomprehensibly cold, colder than Antarctica, colder than the coldest places we've ever recorded on Earth. Meanwhile, the equator becomes a furnace. If somehow life had emerged in this world, it would face the cruelest choice: freeze or burn. There is no temperate zone, there is no comfortable place to evolve. Here's where it gets truly grim. Without liquid water, the rich chemistry that enables life ceases to exist. Organic molecules, the basis of all life, require liquid water to form and function. They require hydrogen bonding, which requires liquid water. They require the solvent properties of water to interact with other molecules. Moreover, without water's protective layer, ultraviolet radiation from the sun reaches the surface directly. No ozone layer forms. Ozone requires water vapor and specific chemical reactions that depend on liquid water. UV radiation tears apart any complex molecules, stripping away electrons, destroying chemical structures. Additionally, the atmosphere becomes increasingly oxidizing. Free oxygen atoms and molecules chemically attack any organic precursors trying to form. It's a chemical environment hostile to biology, not just challenging, but fundamentally incompatible with the emergence of life. We don't just lose oceans, we lose the possibility of chemistry itself. The possibility of organic molecules existing long enough to interact, combine, and evolve. We've discussed what's missing.
Now, let's examine what remains and how it behaves. An atmosphere without water vapor is fundamentally different from ours. Weather systems that drive weather on Earth don't work the same way. Weather on Earth is driven largely by water's phase changes. Evaporation absorbs energy and lifts air. Condensation releases energy, creating convection. These processes drive circulation patterns, jet streams, the entire global weather engine. Remove water, and this engine stalls. Weather doesn't disappear entirely, but it becomes fundamentally different. Wind patterns would be driven by bare thermal differences between equator and poles. No convection currents powered by condensation. No latent heat release driving storm systems. The atmosphere becomes almost static. Winds blow, but they blow in predictable, almost linear patterns. Equatorial heating creates a gentle upwelling. Polar cooling creates gentle downwelling. But the dynamic, chaotic, complex weather we know, hurricanes, thunderstorms, jet streams, those require water.
One of the most striking visual changes would be the complete absence of clouds. Every image of Earth we see, satellite imagery, astronaut photographs, shows clouds. Brilliant white clouds sculpted by convection, spiraling around storm systems, painting the face of our world. In this scenario, clouds simply don't exist. The sky would be perpetually clear, a uniform, perhaps slightly hazy blue, or, given the oxidizing atmosphere, perhaps more of a rust or tan color. The sun would be visible every single day at the equator. No rain shadow effects, no cloud cover moderating temperature. But paradoxically, the sky might also appear hazier. Without rain to wash the atmosphere, dust and particles would accumulate. Wind would lift fine particles of oxidized rock and soil. These particles would create a perpetual haze. The horizon would blur into the sky. Distance visibility would be limited. It would be dusty always. Additionally, auroras would be more frequent and more intense. With less atmospheric water to shield the upper atmosphere, more solar wind interaction with the magnetosphere would create more vivid auroral displays. But this is cold beauty, the only color in an otherwise barren sky. Free oxygen in the atmosphere doesn't just drift. It chemically interacts with everything. The upper atmosphere becomes a hostile, oxidizing environment. Nitrogen oxides form through various processes, but unlike Earth, where water moderates these reactions, they accumulate. The result is a chemically reactive upper atmosphere that's actively hostile to any organic molecules. Any complex chemistry that might arise is immediately attacked and destroyed. Additionally, without water to participate in certain atmospheric chemical cycles, the atmosphere becomes increasingly alkaline and oxidizing. Volcanic gases that emerge from the planet's interior, sulfur dioxide, carbon dioxide, aren't converted or dissolved by water. They remain in the atmosphere, accumulating over geological time. The atmosphere becomes increasingly acidic with sulfuric components, caustic with metal oxides, hostile to any form of life. It's not just that water is missing. It's that the atmosphere without water becomes actively toxic. Without an ozone layer,
ultraviolet radiation becomes a primary force reshaping the planet's surface. UV light is energetic enough to break chemical bonds, to ionize atoms, to damage DNA, if DNA could even exist here, which it cannot. The surface would be bathed in intense UV radiation, especially at the equator and in the upper atmosphere above the poles. Rocks exposed to this radiation would undergo photochemical weathering, literally being altered by light energy. Complex minerals would break down. Surfaces would become chemically unstable. Any organic molecules that somehow miraculously formed would last only seconds before being torn apart by this radiation. It's not just that life can't emerge here. The universe of chemistry is constrained. Simple molecules, simple reactions, simple stasis. It would be the most chemically boring place in the solar system. No complex chemistry, no dynamic processes, just atoms slowly oxidizing, simple molecules being photodissociated, eternal chemical sterility. Without liquid water to anchor soil, to bind rock together, without vegetation to hold surfaces in place, the landscape becomes vulnerable to wind. The simplistic wind patterns we described earlier, driven purely by thermal gradients, create consistent, predictable winds. But these winds, blowing across bare rock and sand with nothing to resist them, would create spectacular dust storms. Not chaotic, violent storms like Earth's, but persistent, relentless wind erosion. Over geological time, mountains wear away, valleys deepen, the landscape becomes increasingly smoothed and scoured. And the dust these winds carry, fine particles of oxidized rock, remain suspended in the atmosphere for extended periods without rain to wash it out. The horizon perpetually hazed, visibility limited, surfaces constantly scoured and blasted by wind-carried particles. It would be a landscape in constant, slow motion. Not dramatic change, but inexorable change. Geology moving almost imperceptibly, but inevitably reshaping itself under wind's relentless pressure. Let's step back and understand what we've created. An atmosphere that's chemically sealed. On Earth, water participates in countless chemical cycles. The carbon cycle involves water. The nitrogen cycle involves water. The sulfur cycle involves water. Water is the medium through which elements cycle between atmosphere, ocean, rocks, and life. Without water, these cycles are broken. Carbon dioxide that escapes from volcanoes doesn't dissolve in oceans or rain. It accumulates. Nitrogen that's processed by organisms, but wait, there are no organisms, stays locked in the atmosphere. Minerals that weather through water-assisted processes don't weather the same way. The result is a geochemically static system. Slow changes driven by volcanic outgassing and solar wind erosion, but fundamentally stable. No dynamic cycling, no life-driven changes. Just geological time moving with ponderous slowness over billions of years. Early in Earth's history, when our planet was young and the sun was dimmer, what astronomers call the faint young sun paradox, Earth somehow maintained liquid water and was habitable. This was possible because of a greenhouse effect from atmospheric carbon dioxide and possibly methane from early microbes. Now imagine inverting this problem. Remove water's thermal regulation. Remove clouds' albedo effects. Remove water vapor's greenhouse properties. You don't get a cooler planet. You get a planet with extreme temperature swings and a fundamentally altered energy balance. The surface would lose heat rapidly at night. Without atmospheric water to trap heat through greenhouse effects, the thermal energy radiates away. Days are hellishly hot. Nights are intensely cold. The day-night temperature differential would be larger than the difference between the hottest and coldest places on Earth. And this wouldn't be stable over geological time. Without water, climate changes would be more extreme in response to solar variability. A small decrease in solar output and the entire planet could enter a runaway freeze. An increase and the surface becomes uninhabitable even at the poles. And so, another journey fades into starlight. If you found peace in tonight's story, let it travel with you into your dreams. Until next time, I'm J.J. Littleton, and this is The Quiet Cosmos.